Hello, honor students, Mr. Lawrence here, and we're going to do a little review of scientific notation covering the basics. In fact, you know what? What you really should do, especially with these four problems, you should solve them on your own. Pause the video right now and convert them to the first two into scientific notation and the second two into standard. You don't need to sit and watch me. You know how to do it. Now, of course, I'll show you my answers, but it should be simple. All right. If you feel the same way about problems 5 through 8, then when I get to those, go ahead and pause the video. Don't just sit and watch me do it. If you know how to do it, you work ahead. All right. There's problem 9, problem 10, and then a how many times larger question. Okay. And again, these should be all be simple. So let's go ahead and you can go ahead and pause now if you like. Please don't just sit and watch me do it. All right, I have to convert this 6,423,000,000 number into scientific notation. Well, I know my decimal point is here. I know it needs to be here. And I'm going to have to divide. And each one of these little guys is like dividing by 10. So I just divided by 1,000. Divide by 10, divide by 10, divide by 10. I'm going to do it again. All right, so I've divided by 10 to the 6th power, 10 to the 7th, 10 to the 8th, 10 to the 9th. So my new number is going to be 6 and 423 thousandths times 10. How many did I divide by? I think I said 9. 3, 6, 9. Yeah, 10 to the 9th. It's too easy. It should be total review. All right. Number 2. I know I need my decimal point to go there. This time I'm actually not dividing by 10, I'm multiplying by 10. How many times? 1, 2, 3, 4. Looks like I'm going to multiply. All right, times, oh, 3, 8. That's, I got confused there, sorry. 10 to the negative 4th. Remember the inverse relationship. If the decimal number gets smaller, which it did in this case. No, it did not in this case. Excuse me. In the first case, the decimal number got smaller. The exponent got larger. Hey, I'm just curious. If I were to multiply this by 10 to some power, and I didn't want the number to change at all, this 6,423,000,000 number, well, what would be the exponent on 10? Hmm. Wouldn't it be 0? Right? 10 to the 0 would be 1, and I'd multiply that by 1. So you see the 6,423,000,000 number went down to 6.423, but the 10 to the 0 number went up to 10 to the 9th. Yeah. All right. So let's check that over here. Looks like my decimal got larger. And so in this case, my exponent got small. Yeah, and the same thing I could say it's times 10 to the 0 if I wanted to. Excuse me. All right. Number 3, we have to convert this to standard notation. Well, I'm multiplying by 10 to the negative 6th. That's a pretty small number. So this decimal point is going to end up moving left. It's like I'm dividing by 10 6 times. So I'm going to have this 5, 2, 2. And when it moves here, that'll be 1 division by 10, 2, 3, 4, 5, 6. All right, so all those little waves will fill in with zeros. And I'll end up with 0.2345, 522. Okay. Um, and now in this one, number 4, I'm going to take 8 and 91 hundredths and multiply by a number larger than 10. So it's got to get bigger. 10 to the 4th, 10,000. So 1, 2, 3, 4, I believe will be right. If you don't believe me, you can go ahead and do the little waves. 1, 2, 3, 4. You'll need 2 zeros, and you'll see I do get the same number. All right, let's drop down to the multiplication and division. Right off the bat, number 6 looks easier. I think I'll do number 6 first. 6 times 5 is, not 20. It's 30. And 10 to the negative second times 10 to the negative 6, wouldn't it be times 10 to the negative 8th? The only problem with this answer is this number is too big. Remember, my decimal portion of the number has to be between 1 and 10. So since 30 is too big, I'm going to have to divide 30 by 10 to get it small enough. Then I'll have to multiply the 10 to the 8th by 10 to the 1st. These two here undo each other. They're inverses of each other. They cancel each other out. Therefore, they don't change the green number at all. Okay, so I'm going to get 3 times 10 to the negative 7th. Yeah, negative 8 plus 1 is negative 7. There you go. All right. Now I'll go back and do 8. I have to multiply 8 and 1/10 and 7 and 4/10. Well, let's see. Oops, don't want to do that. We got 32 and 7 is 39, 356. Okay, I believe it's going to end up being 59 and 94 hundredths times 10 to the 8th. I've got a problem again. My decimal number is too large. So I'm going to divide it by 10 and then multiply by 10 over here, turning my number into this to the ninth, not changing the value of the number, just changing the way it looks. And now it's in scientific notation. All right, division is done pretty much the same way. I'm thinking that that's going to go like 4 exactly when I divide 8 and 4/10 by 2 and 1/10. Yeah, that should be 4 exactly times 10 to what power? Well, if you get screwed up on this, you could go back and think about it like this. It's 10 to the negative 8th uh, over 10 to the negative second. And if you wanted to flip them, like we did in the last unit, you could say that's 1 over 10 to the 6th. Now, the only problem is we don't use division in scientific notation. So I would want to take this guy back upstairs, and that would force his exponent to become negative. And so it'll be 10 to the, oops, I already have the 10 part down, sorry. 10 to the negative 6th would be your answer. All right. Now, if you wanted to, you could do 10 to the negative 8th minus a negative 2. And those two would change to positive, and negative 8 plus 2 is negative 6. A couple different ways to think about it. I know some of you have a little sign trouble, especially when I don't let you use calculators. All right. Number 7. Ooh, I don't know this one off the top of my head. You know what? I won't give you one like this without letting you use a calculator, but I'm going to do this bizarre one just to show you how it works. Um, so let's go with, what is it, 7.704 and 642. Get onto Google here. Oops, having a little trouble. Hold on a second. Okay, I got my trouble sorted out, so I'm going to divide 7 and 704 10,000ths by 6 and 42 hundredths. And on my Google calculator, tell me that's 1 and 2/10. And so when I jump back over here, I'm going to get 1 and 2/10 times 10 to the, well, I've got 7 minus negative 2 minus a negative is plus a positive. That'll be to the 9th power. And there you go. All right. Addition and subtraction. Remember, this is all about like terms. The exponents must match. If they don't, I like to make my smaller one turn into the larger exponent. How do I do that? Well, of course, I multiply it by 10, which means I must divide by 10 over here, which moves my decimal point, right? So now my new problem is 3 and 33 hundredths times 10 to the fifth. I left myself a little space. And I'm going to add this to it. And I'm going to get 3.552 times 10 to the fifth. If I would have chosen to move this decimal point to change the 5 down to a 4, it would have been like the last couple problems where my decimal would have been larger than 10 and I would have to convert it down a little bit. Not a big deal, just an extra step. Okay, on a subtraction one, please notice that this number, this 8.79 times 10 to the negative seventh is 10 to the negative second is larger than 3 and 24 hundredths times 10 to the negative third. If it wasn't, I'd end up with a negative result. Remember, I like to change the smaller one to match the larger one. How do I do that? By multiplying by 10 to the first. Here I'll divide by 10 to the first, right? So I'm going to have 8 and 79 hundredths times 10 to the negative second. And I'll be subtracting 0.324 times 10 to the negative second. Need a placeholder in here of a 0, right? And I'm going to do a little subtraction now, and I'll have to do some borrowing. Turn that into an 8, so I'm going to get 6, 6, 4, 8 times 10 to the negative second. Pretty easy stuff, okay? Um, yeah. Okay, here's a story problem where it says the population of Sydney, Australia is 4,667,000. Population of Hervey Bay, Australia is approximately 50,400. All right, convert these populations to scientific notation and determine approximately how many times larger. Now, some of you will just want to divide, but we want to practice dividing in scientific notation. So first I'll do Sydney, which is going to have to be, right? And how many times? Well, it looks like it's going to be times 10 to the sixth. 1, 2, 3, 4, 5, 6 right there. Yep. So that's times 10 to the sixth. Okay. Now this one is going to be 5.04 times 10 to the 1, 2, 3, 4. Is that right? Yeah. So I have divided by 5.04 times 10 to the fourth. Now, we're doing approximately. It is totally okay in an estimation situation for you to think about this number as, say, 4.5. Okay, it's a little bit off, right? Okay, it's going to be a little bit more than that, but I'm going to do 4.5 times 10 to the sixth. And I'm going to divide that by 5 times 10 to the fourth. Okay, it's only in an estimation situation. Well, I know that 45 divided by 5 is 9. So 4 and 5 tenths divided by 5 must be 9 tenths. So I'm going to get 9 tenths when I do this division. Now when I do this other division, 10 to the sixth divided by 10 to the fourth, and that's going to equal 10 to the second, or better yet, 100. Okay, and so when I multiply this by 100, I'm going to get, sorry, that decimal point should be there. It looks kind of strange as high up as I had it. Okay, so I'm going to have 0.9 times 10 times 100. Looks like it's going to be 90 times larger. Okay, approximately. We're only estimating. Let's go back to Google here for a second. And I'm going to divide the decimal portion of the number And look, I got 0.925992, and I estimated that was going to be about zero point 0.9 when I did my division. Now I was going to multiply by 10 to the 10 squared, and I'll just do 100. And look at that, it's 92 and 6/10 bigger. So I'm off by 6/10, but was only an estimation. So I consider that to be a pretty good solution. All right, you'll be having a quiz coming up real soon here, probably Wednesday, over this material for the honors class. The level 2 class, the quiz will probably be Thursday. All right, Mr. Lawrence signing off. Have a good night, everybody.